And we've all heard of mind over matter, but is it possible that the right motivation can actually help repair spinal damage?
I've come to Lausanne, Switzerland to find out about some innovative research being done to repair the spinal cords of rats using pharmaceuticals, electrical signals, and the key ingredient, motivation.
Sometimes with the right motivation, anything is possible. Très bien.
The main function of the spinal cord is to transmit neural signals or messages between the brain and the rest of the body. So when the spinal cord is severed or crushed, these messages can't get past the injury. The result is often chronic paralysis. Research in this area generally focuses on regenerating damaged nerve fibers. But here in Lausanne, they're taking a different approach.
Bonjour, Derek.
Bonjour.
Welcome in the lab.
Ah, thank you.
Professor Courtine's work with rats is producing remarkable results.
So I thought, well, can we actually deliver to the spinal cord the kind of information that the brain would deliver naturally in order to walk?
The rats have their spinal cords cut in 2 places. Although not completely severed, signals can't get past the lesion, leaving the rats paralyzed. To reactivate the healthy but disconnected neural cells below the injury, the researchers administer a cocktail of synthetic neurotransmitters, followed by electrical stimulation.
I'm plugging the cable that connects to the electrodes on the spinal cord, so we can provide the stimulation to the spinal cord.
Okay, so there are cables that run down the spinal cord?
It actually runs under the skin, and then it's sutured on top of the spinal cord.
This electrochemical combination mimics the input of the brain and reawakens the spinal cord below the lesion.
No, I start the treadmill immediately. Oh, she will start walking. It's amazing, right?
The result? After a few weeks of training and while on the treadmill, the rat is incredibly able to walk again.
So this animal was completely paralyzed 5 minutes ago, and now she's continue stepping on the treadmill. And I will go at running speed. Immediately, up, the animal is capable of literally sprinting on the treadmill. And look at this, you cannot even do it yourself. I will stop the treadmill, up, she stands immediately.
But this is happening without the involvement of the brain. At this stage, the rat's stepping is stimulated by the treadmill. The legs are moving independently of the brain, so the movement is completely involuntary.
You can train the rat on this treadmill for 2 months. You will not see recovery of voluntary control. Why? The brain is not involved. There is no motivation to walk because you see that the rat...
Motivation is the key to restoring voluntary movement. So this is where the irresistible Swiss chocolate comes in.
I brought a chocolate eclair. I ate half, but the other half is for the rat.
Yeah, see?
She does like it.
She likes it.
We have a combination of actually yogurt and chocolate, which the rat love.
This reward-based training, without a treadmill, was the focus of the next phase of research.
I have to get her in the right position.
They designed a special robot which only supports the paralyzed rat but doesn't propel it forward.
This means that the rats really need to generate the propulsive forces to go toward the reward, which is the chocolate.
So the rat is asked to go push herself forward, but she does get a little bit of help up and down.
The rats have again been given electrochemical stimulants, but without the treadmill, the rat has to decide for itself if it wants to walk.
When you want the animal to participate very actively, I mean, we're talking about the championships rehabilitation, you need to motivate the rat at any cost.
Come, 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 come.
So Rubia does whatever it takes to coax the rat to walk.
Come on, jump, go forward, come on. Push them, push, sweetie, come on. Keep going, keep going. Go.
The rat is now walking when it wants to, which means the brain's signals are getting through to the previously paralyzed limbs.
Wow, she's done really well.
Yeah.
The rat's spinal cord seems much more capable of rewiring itself than anyone expected. In one of the most extensive examples observed, it's been able to detour around the injury and reconnect the dormant neural network.
What we observe is that the cut fibers, basically, they grow and deliver to this neural network below the injury enough information we don't know what kind, but sufficient information from the brain to have a voluntary control.
What we're hearing is evidence of the rat making the decision to walk.
The popping sound is a neuron firing, and here she's just standing, but you'll see once she starts walking, there's a pretty clear pattern of the activity of the neuron with the rat stepping.
It's showing that the movement is voluntary.
That's really cool. That was really exciting the first time that happened, because we had this idea that the brain should be involved, but it hadn't been proven.
Come.
There's a whole team of people working, and everybody's pushing the rat, and everybody's, oh, go, go, go. And I could hear it before it happened, and I really knew, okay, it's going to work this time.
Perfect.
Wow.
With half of all human spinal injuries leading to chronic paralysis, Professor Courtine's research gives new hope to those affected.
So of course, the next obvious and exciting goal is to try this type of intervention in humans. It's difficult to say what this will achieve in humans, but it's a very promising new path.
So what I'd like to do is a kilometer concept. It's satellite to be sent into space to broadcast some space jumpers, in this case Swiss cubes, and bring it back into the atmosphere where it will burn up fundamental matter. But to rendezvous with